Hi everyone, in this video we're going to go through the first module of Datacamp's free Introduction to R course, Intro to Basics. Hi everyone and welcome to the Datacamp Introduction to R course tutorial. The reason why I decided to do this particular video is that a lot of times graduate students or colleagues will come up to me and ask me how to get going on R in an easy and efficient way. And there are a lot of online tutorials, there are a lot of R textbooks that are available, but the reality is that when you're learning a new program language, you just have to dive in and you have to be able to work on it with your fingers to the keyboard to really absorb the material cognitively. And I found that just reading books or looking at tutorials and just running R on your own and trying to figure it out isn't quite efficient. Datacamp has a free Introduction to R course that I often send graduate students or colleagues that are interested in learning R. I generally send them to this website to work on the free course because it's web-based and it mimics the R software in a way to where they give you problems, they introduce concepts, and they allow you to work on them, and they have a package that they've written that works in the server that checks your code and it gives you hints if your code isn't correct. And so I found this to be a pretty efficient and easy way to get going with R for free, and it seems to be helping people. So I thought it would be a good idea to go through the modules and give some thoughts and feedback in terms of what we're doing and what some of the functionality means in terms of using it in the context of research. So you see in this course there are several modules that we can work through. The first is Introduction to Basics. The second is Vectors, then Matrices, Factors, Data Frames, Lists. And so really this is the foundational use of really any programming language. And when you're starting to get going with R, I think it's really important to understand that it's not necessarily that I'm learning R. What you're really learning is coding, and you're learning a computer program language, and you're just using the R mechanism to do that. So there are multiple languages that you can learn, and a lot of this stuff is congruent with all of those different languages, but we're just using it in R, so maybe the syntax might be a little bit different than, say, something like C++ or Python or any other programming language. So think about it as you're learning a program language within the context of R. You're not necessarily learning R. All right, so I figured what we can do is we can get going with Intro to Basics. This particular module, it talks a little bit about using arithmetic in R, assigning variables, and some of the basic data types that we can use within the programming language. So let's get going working with it. This is the first page, and when you log in, you're going to see that it mimics somewhat of an R computing environment. So we have the script up here, and we have the console down here. And what this first little exercise is telling you is that it uses comments. And so comments are really important for two reasons, and you'll see them in any programming language. And in R, it's denoted with a hashtag and then some sort of text written after the hashtag. And the reason why we use comments is basically it's all underlying for logic. And there's two different components to that. The first is to indicate to yourself what you're doing in the script, what you're doing in the coding, and to remind yourself why you're doing it, the logic behind you doing it. A lot of the times you might work on a script, you might work on a project, put it away, and then maybe 6 months later come back to that project, and you're never going to remember why you were doing particular functions or why you were running particular scripts. And this is just a key reminder to bring you back to the logic of why you're running particular things. And the second is that the great thing about R is that you're able to share the scripts, and what it does is it helps support reproducible research. And so when you share your scripts with people, what you want them to do is to understand the logic as to why you are doing what you're doing within the script itself. So you can denote everything with a comment. And what this means is that anything after the hashtag you can write, and it won't be read into the console, and it won't be read as part of the coding that's happening. So this is just a really clear and easy way to indicate the logic of what you're doing within your script. Here in Datacamp, they generally use these comments as places to work, and they'll give you instructions within the script to execute certain code. And so here it's just telling you that we can add 3 plus 4, and here it's telling us that it wants us to calculate 6 plus 12. So I'll come in and calculate 6 plus 12. What I'll do is I'll highlight everything here and I'll click Run Code, and then that'll run into the console. It's giving us the answer that 4 plus 3 is 7, 12 plus 6 is 18, and then we're just going to submit answer. Now you're not going to see these boxes in the real R programming language. This is here as part of the package, so that way it can give you some hints as to whether or not you're running everything correctly. So we'll click submit answer. It tells us that we're correct, and we'll click enter to continue. Okay, so the basic thing that you can do in pretty much any program language is basic arithmetic. So R at its most basic functionality is a really sophisticated calculator. So it's telling us here that we can do addition, 5 plus 5. So if I just highlight this and run the code, it'll give us the answer of 10. We can do 5 minus 5, we'll run the code, answer is 0. We can run the code of 3 times 5. Now I'm highlighting the comments, you don't necessarily have to. We can do division, and then also remember here that it's indicating that it follows the standard order of operations. So we'll just run the code, it'll give us the answer. And now exponentiation, so in the instructions here it's telling us type 2 to the 5th power in the editor to calculate 2 to the power of 5. And so we use the caret symbol to do that. So I'll just do 2 with a caret 5. I'll run this, and it gives us the answer of 32. And then we also have the modulo, so 28 with the 2% signs, it's indicated with 2% signs, and the number 6, and we get the answer of 4. So what I'll do now is I'll just highlight everything in the script, I'll submit the answer. It checks, as right now it's checking to make sure we did everything properly, that the code is right, the answers are right, and we did it right, so we'll click continue. Okay, so variable assignment. A basic concept in programming is called a variable. A variable allows you to store a value or an object in R. You can later call back these values through the variable's name to easily access the value or the object stored within it. A really basic principle is that we can use a lot of different functions, and we can use matrices and arrays, and we can do all of these types of things, and we can assign them to a particular variable. It talks a little bit about that in some of the later exercises. But essentially what we're doing is we're taking stored values or stored calculations and assigning it to a variable. And so in this case, we can store just a basic number to x. So we can say that x is 42. And we use this symbol, it actually denotes the it's equals, but we call it gets. So x gets 42. And then, so we're gonna assign this, I'll run the code, and now it's gonna tell us that the number 42 is assigned to the variable x, and then we can now print out x. So I can just run this code, and the answer comes back as 42. We're assigning the value 42 to the variable x, and then we're printing out x to verify that that number has been assigned. So we'll submit answer and continue. Okay, so here it's giving us a working example now. Suppose you have a fruit basket with 5 apples. As a data analyst, you want to store the number of apples in a variable, and you want to name it my apples. So here what it's telling us is it's important to understand that when you label something a variable, we don't necessarily just want to label it X. You can, and maybe there are times that you want to do that, but the variable name has to be informative. We want it to describe what the numbers mean within that context. So here it's telling us to assign the value 5 to the variable my apples. So essentially what we're saying is that we have 5 apples and we want to call them my apples. Think of it as putting 5 apples in a basket and then labeling your basket my apples, right? So we'll just type my apples gets 5. We'll run this to the code so it goes into the console, and then what we're going to do here is that we're just going to print out my apples to verify that it is the number 5 and it's been assigned. Okay, so that's what it's asking to do. So I'll click submit. Great. Okay, and so now every tasty fruit basket needs oranges. So now you have 6 oranges that you want to add. As a data analyst, your reflex is to immediately create the variable my oranges and assign the value 6 to it. Next, you want to calculate how many pieces of fruit you have in total. And so what it's asking us to do is that we want to assign, we've already assigned 5 to my apples. Now we want to assign 6 to my oranges. And then we want to see how many pieces of fruit that we have together, so we can add the variable my apples, and we can add, which is assigned the number 5. We can add my oranges, which is assigned the number 6, and it should give us the answer of 11. Let's try and do this. We've assigned already my apples 5 in the previous script, so now we're going to do my oranges gets 6, and we're just going to run these and put it in so make sure it locks in. Okay, and then add these 2 variables together. So my oranges plus my apples Let's see what the answer is. The answer comes out as 11. And then now we want to create the variable my fruit. So later we might just always refer to my oranges and my apples just grossly as my fruit. And so an easy way to do this is to assign the addition of both of these to a new variable and call it my fruit. So my fruit gets my oranges plus my apples. Okay, and we're going to run all of the code and submit the answer. Okay. So common knowledge tells you that you cannot add apples and oranges, but hey, you just did, right? And so the my apples and the my oranges variables both contained a number in the previous exercise. The addition operator or the plus operator works with numeric variables in R. If you really tried to add apples and oranges and assigned a text value to the variable my oranges, you'd be trying to assign the addition of a numeric and a character variable to the variable my fruit, and this is not possible. So basic arithmetic operators in R, we can use those essentially to add numerics. And so what this is telling us is that if we assign a character variable to my oranges, so instead of the number 6, we put the character 6, which is indicated as a string of characters within quotation marks. It's telling us that we can't add the number 6 and the number 5. And so we can actually try this. Let's go into the console and see what happens. So let's add my apples, and we'll add my oranges. Well, I think first what we should do is we should run this. Let's run this code so that the assignment is there. Okay. And now we want to do my apples plus my oranges. And let's see what happens. We should get an error. Okay, so I just ran the code, and it's telling us essentially that we cannot add a character variable to a numeric variable, and it gives us an error to do so because they both have to be numeric, right? So what we want to do here is we want to change this 6 to a 6, and we'll run the code again, and we get the answer of 11. Okay, so in any programming language, there are basic data types that we use. And understanding the basic data types is really important because we want to understand what particular operations we can use on the variables. So in basic data types, we have decimal values. So 4.5, we call those numerics. A lot of the times in other programming languages, they're called floats. Here they're called numerics. And natural numbers like 4, those are all integers. We have logicals, which are true or false. And then we have characters, which are a string of text. And as we've seen earlier, they're indicated by a string of characters within quotations. What this is asking us to do is that we want to change the numeric value to 42. And we want to change the character to universe. And we want to change the logical to false. Run the code. Okay, everything's been changed. We'll submit the answer. What's that data type? When we added 5 plus 6 earlier, you got an error because they were mismatched data types. So we can check what type of data type is attached to a variable by running a function called class. Class is going to indicate whether or not it's each of those data types. It says complete the code in the editor and also print out the classes of my character and my logical. Okay, so declared variables. So they've already done this for us. So let's run these. Now it says check the class of my numeric. So we would type this in. It's already been typed in for us. We'll run the code, and it's telling us that it is indeed numeric. So number 42 is a numeric. So now we want to check the class of my character. So the class of my character, because it's a string of characters in quotations, we would think that this is a character. So let's double check that and make sure. So class, my character. Let's not put it in the console, let's run it right here. Okay, and we'll run the code, and it tells us here that it is a character. And the last thing we want to do is check the logical. So we'll check the class of the logical. And we'll run the code, and it tells us that it's a logical. So why would we want to do this? Well, a lot of the times we'll receive data that isn't ours, and we'll have to run an analysis on it. and we're not necessarily sure how R will react to the data coming in. It will automatically assign a data type based upon what it thinks it is coming from the data source. However, it might not always be correct, and we just want to double check the data types to make sure that it is properly aligned, so that way we don't get errors down the road when we're calling commands or doing functions, and we get errors because it's assigned the wrong data type. So we always want to make sure that the data types are correct in the interpretation of the data type. So the next thing we'll be working on are vectors. I hope you enjoyed the video and found it helpful. If you did, make sure to give us a big thumbs up and like the video. If you haven't done so already, be sure to subscribe to our channel by clicking the link above, and make sure to check out some of our other videos. We'll see you again soon.